What would a magnitude 15 earthquake be like? It's a question that gets asked sometimes by people who are curious about the limits of our planet. After all, earthquakes are one of the most powerful natural forces on Earth. They reshape landscapes, destroy cities, and can kill thousands in minutes. We've all heard about magnitude 7 or 8 quakes, the kind that level buildings and make headlines around the world. But what if the numbers went even higher? Could the Earth produce something as massive as a magnitude 15 quake? And if it did, what would it look like? Let's start with the problem. The earthquake magnitude scale most of us are familiar with is the Richter scale, developed in the 1930s. But today, scientists use a more accurate measurement called the moment magnitude scale. It measures the energy released during an earthquake. The key thing to know is that this scale is logarithmic. That means each whole number step up on the scale equals about 32 times more energy released. So a magnitude 8 quake isn't just a little stronger than a 7, it's more than 30 times more powerful. A magnitude 9 is more than 1,000 times stronger than a 7. The largest earthquake ever recorded was a magnitude 9.5 in Chile in 1960. That quake killed more than 200,000 people, than 1,600 people, and triggered tsunamis that crossed the Pacific Ocean, damaging Hawaii, Japan, and the Philippines. It even caused the entire Earth to vibrate slightly and permanently shifted parts of the Chilean coastline by several meters. In 2004, the Indian Ocean earthquake, magnitude 9.1, generated a tsunami that killed more than 220,000 people in 14 countries. These events show just how devastating a high 9 magnitude earthquake already is. But a magnitude 15? That's another question entirely. Here's where the agitation comes in. A magnitude 15 earthquake would release so much energy it defies our normal understanding. To put it into perspective, a magnitude 10 quake would release about 32 times more energy than a 9. A magnitude 11 would be another 32 times beyond that. By the time you get to magnitude 15, you're talking about energy release that's more than 1 billion times larger than the biggest quake ever recorded. And here's the catch. The Earth itself can't physically produce something like that. That's because the strength of an earthquake depends on the amount of rock that can move along a fault and how much energy can build up before the rock breaks. Earth's tectonic plates are only so thick, and the biggest fault zones are only so long. A magnitude 9.5 quake happens along a fault that stretches hundreds of kilometers. To produce a magnitude 15, you'd need a fault thousands of times bigger than the entire planet. In fact, calculations by geophysicists have shown that the absolute theoretical upper limit for an earthquake on Earth is somewhere around magnitude 10 or slightly above. Beyond that, there just isn't enough rock under enough stress to release that much energy. So a magnitude 15 earthquake is not just unlikely, it's impossible. Not just improbable, but physically beyond the limits of our planet's structure. But for the sake of argument, let's imagine something else entirely. What if some cosmic event somehow injected that much energy into Earth's crust at once? What would it look like? It would make every earthquake in history look insignificant. The ground would rupture on a planetary scale. Entire continents would shift. Mountain ranges would crumble. Oceans would boil as massive displacements of rock released unimaginable heat. Tsunamis hundreds of meters high would race across the globe, drowning entire countries. And it wouldn't stop there. The sheer energy would likely crack the planet's crust so deeply that it could trigger massive volcanic eruptions worldwide. Ash clouds would block the sun. The atmosphere itself could be disrupted. In the worst case, the entire planet could become unstable, possibly breaking apart. There is no modern case study that comes even close. But we can look to the early history of the solar system for an example of how much energy it takes to destroy a planet. About 4.5 billion years ago, Earth itself was struck by a Mars-sized object in an impact so violent it melted large parts of the crust and threw enough debris into orbit to form the Moon. That collision released energy far beyond anything a magnitude 15 quake would deliver. Even in recent history, the 2013 Chelyabinsk meteor over Russia, which was just 20 meters across, released energy equivalent to about 400 to 500 kilotons of TNT, roughly 30 times the Hiroshima bomb. and it was nothing compared to a magnitude 15 event. So what does all of this tell us? It tells us that the Earth does have limits, and understanding those limits is crucial. Here's the solution. When people ask about a magnitude 15 earthquake, what they're really asking is, what are the limits of what Earth can endure? And the answer is, we already know the boundaries, and we're already living within them. The most powerful forces on Earth come from its own internal dynamics, and the biggest earthquake it can produce is somewhere near a 10. Those quakes are already rare, happening perhaps once in thousands of years. But even much smaller quakes, in the 7 or 8 range, are devastating enough to remind us how vulnerable we are. So instead of worrying about impossible events, the practical thing we can do is prepare for the very real and very possible ones. Case studies from Chile, Japan, and Indonesia show that early warning systems save lives. In Japan's 2011 Tohoku earthquake, the early warning system gave people between 30 seconds and 2 minutes of warning. That doesn't sound like much, but it was enough to shut down trains, stop surgeries, and let thousands of people take cover before the shaking hit. Stronger building codes also save lives. After California's 1994 Northridge earthquake, which killed 57 people, the state updated its seismic building standards. In the years since, newer buildings have withstood significant earthquakes with less damage. Community education is another key factor. In the 2004 Indian Ocean tsunami, many more people might have survived if they had recognized the early warning signs, the sudden retreat of the ocean, and moved to higher ground. In contrast, when a similar tsunami struck Japan in 2011, more people understood what was happening and reacted more quickly because of prior education. The reality is, we don't need to imagine impossible disasters to see how fragile our world can be. Even the possible ones are enough to remind us what's at stake. And yet, this is not a reason to despair. It's a reason to act, a reason to invest in science, infrastructure, and education that help communities survive and recover. A reason to respect the power of the Earth, and to remember that while we can't control it, we can adapt to it. So next time someone asks you what a magnitude 15 earthquake would be like, tell them this: it would be the end of the world. But it can't happen here. And that's good news, because it means our real focus should stay where it belongs. On preparing for the earthquakes that actually can happen, on saving lives when the next big one strikes, and on building a world strong enough to stand even when the ground itself shakes beneath our feet. One decision at a time, one life at a time. Because the most powerful forces on this planet aren't measured in magnitudes, they're measured in how we choose to respond.